Now the question 31 says that a flocculation tank contains 1800 meter cube of water mixed using the paddles at an average velocity gradient of 100 per second. Water temperature and corresponding dynamic viscosity uh, is 0.798 into 10 to the power minus 3 Newton second per meter square. Theoretical power they want to know in kilowatts. Okay, let's first of all write what's given. Volume 1800 meter cube. Value of G is 100 per second, and the viscosity is, that is dynamic viscosity, 0.798 into 10 to the power minus 3. Now they want to know what is the value of power. So the formula is very simple. We know that G is equal to under root P upon mu V. The question is very simple if we understand, if we know the formula, and if we put the values. It is just a value putting question. G is 100, under root, that means square, will be equal to power upon 0.798 into 10 to the power minus 3, and velocity as well, that is 1800 meter cube. Question is very easy. We don't even need to change the units also into the standard form. Everything is pre-given and we just have to put into the formula and find out the answer. So the power value comes out to be 10,000 into 10 to the power minus 3 into 0.798 into 1800. So after calculating, the answer comes out to be 14,364 watts, and if we change it into kilowatts, because they are asking in kilowatts, so it will be 14.364 kilowatts. This is the value of power, right? So the answer is 14.3 up to 2 decimal place, so 14.36. We can leave this. Let's move on to the next question, which is 32. At a small water treatment plant which has 4 filters, rate of filtration and backwashing are rate of filtration, rate of backwashing. Backwashing is done for 15 minutes per day, and maturation it takes 30 minutes. It is proposed to recover the water being wasted during backwashing and maturation. Percentage increase of filtered water produced up to 2 decimal place would be. So the question says that there are 4 filters and the rate of filtration and backwashing are 200 and 1000 meter cube per day per meter square. Backwashing is done for 15 minutes per day, and for maturation, which occurs initially as the filter put back into service after cleaning, takes 30 minutes. It is proposed to recover the water being wasted during backwashing and maturation. The percentage increased in the filtered water produced will be. So I have written the data that the rate of filtration is this, rate of backwashing is this, and the time taken in backwashing is this much. So can I find out the water used for backwashing? Yeah, definitely. So water used for backwashing can be calculated, because rate of backwashing is 10,000 and time is, it is taking for 15 minutes. I got the volume and it is minute. This is 1000 per day, so I need to change it into day, which will be 24 into 60. So the value comes out to be 10.4166 meters cube per meter square. I can say that. All right, now if I want to calculate the water used for maturation, that comes out to be, the rate of filtration is 200 and The time for maturation is 30 divided by 24 into 60. So after calculating, it comes out to be 4.166 meter cube per meter square. This is the water used for maturation. And do we know the duration of filtration? Can we calculate it? Yes. Total we have 24 hours in a day, right? Out of that, 15 minutes are going in backwashing and 30 minutes are going in maturation. Minutes converted into hour, it comes out to be divided by 60, and the value comes out to be 23.25 hours. So total time it is taking for filtration is 23.25 hours. Okay. Now the amount of water that is getting filtered per day, if I want to calculate amount of water filtered per day, it comes out to be, we have the amount of water that is total, I want 200 meter cube per day, out of which 10.4166 is getting away by backwashing, and out of which 4.166 is also going in maturation. So this comes out to be the rate of filtration, right? Now for 23.25 hours, this value is in days per day and this is in hours, so I need to divide it by 24. So the value comes out to be 185.4167 meter cube per meter square per day. Okay, now if I want to know total water wasted by backwashing, total water wasted is 10.4166 plus 4.166 comes out to be 14.58 meter cube per meter square per day. Okay, so see, the total amount of water filtered per day is this much, total amount of water wasted is this much. If I want to know the percentage increase in filtered water, this is the wasted water, and if I save this water, so the percentage increase of filtration will become 14.58 divided by 185.416 into 100 comes out to be 7.865%. So the answer will be, to two decimal place, 7.87%. So the next question says that a municipal corporation is required to treat 1000 meter cube per day of water. It is found that on an overflow rate of 20 meter per day will produce a satisfactory removal of the discrete suspended particles at a depth of 3 meters. Alright, the diameter of a circular settling tank designed for the removal of these particles would be. Okay, see, we have given the discharge, that is 1000 meter cube per day. We have given the surface overflow rate, that is equal to V naught, and that is 20 meter per day. If I want to calculate the surface area of the settling tank, is nothing but Q upon SOR. Q is 1000, SOR is 20. So we got the surface area is 50 meters square. Okay, now I have the surface area of the settling tank. I want to calculate the diameter of the circular tank. If the tank is rectangular, the surface area will be B into L, and if the tank is circular, the surface area will be pi d square by 4. So now I have the surface area. I can say pi d square by 4 is equal to 50, and from this I got d square is equal to so d is equal to d comes out to be 7.978 meters. I want the answer in the rounded to nearest integer. So the answer we will put is approximately 8 meters. So the diameter of the circular settling tank is 8 meters. Next question says that a surface water treatment plant operates round the clock with a flow rate of 35 meter cube per minute. Water temperature is 15 degrees Celsius and jar testing indicated an alum dosage of 25 milligram per liter. GT is equal to 4 into 10 to the power 4, producing optimum result. Alum required for 30 days in kg. So in this question, the discharge is given, that is 35 meter cube per minute, and the alum dosage is given, 25 milligram per liter. This much thing is required for solving this question. This GT value is not at all required. How? See, if I multiply it by, they just want the discharge value, right? They just want not the discharge, they are wanting the dosage for 30 days. This much milligram per liter dosage is given, and how many liters on meter cube of water per minute will go is also given. So if I multiply 35 meter cube per minute by the dosage 25 milligram per liter, 35 meter cube per, if I change the minute into days, that comes to be 60 into 24, and 25 milligram is nothing but 10 to the power minus 6 kg divided by liter. Liter is nothing but 10 to the power minus 3 meter cube, right? Meter cube to meter cube cancelled. Whatever value is there, 16 to 24 into 25, and this 10 to the power minus 3, it cancelled out to be 10 to the power minus 3 kg per day. This much value kg per day comes for the alum dose. So I have changed it that how many kgs of alum will be required per day. So if I calculate it, 35 into 60 into 24 into 25 divided by 1000, it comes out to be 1260 kg per day. This is for one day, and if I multiply it by 30, so for 30 days will be 1260 kg per day into 30 days. So it get cancelled out. I get the answer as 37800 kg of alum will be required in a month, or we can say 30 days. So the answer will be 37800.